Hey guys, welcome back. Good morning. Good to see you all today. Uh, we'll just be starting off in about like 4 minutes. So thanks everyone for taking the time this morning and being here. I know it's been a kind of crazy day with the election yesterday, but anyways, hopefully you got some good rest. And we'll be starting in a minute. Okay. Feel free to say hi or anything else, as usual. Okay, just another few minutes. Okay, guys, just another minute pretty much. Hello, Eva. Good to see you. Good morning. Hey, Drew, Kelly. Good to see everybody here. Okay, guys. So, good morning. Welcome back. It's 9 a.m. So let's just get started. Thanks again for being here. Maybe some of you have been following the election. I'm definitely one type of person who is very much a big consumer of the news. So I'm always paying attention to the headlines, and I have all these different news apps. So I'm constantly looking for breaking news updates. I just like to stay informed. So for me, I've been closely following the results, and it's definitely a little bit of a different type of election year with all the mail-in ballots coming in. So in a way, it's still election night for, I guess, a little bit longer. But anyways, I can relate and understand if any of you guys felt a little bit distracted or otherwise preoccupied with the functioning of our election and our democracy. But the show goes on. We're still here for philosophy, and anyways, welcome back. So I'll just continue in the same order, going through our notes. We're up to date on the syllabus. We're following the calendar of dates. The final essay, the second essay, is going to be assigned to you guys next week. So it's due in 3 weeks from Friday. So my normal method is to give you about 2 weeks to work on it. So in the middle of next week, you'll get that, and we'll go over the prompts. But for now, let's just continue to focus on our material on time and metaphysics of time. And that's what we're going to close with today and on Friday. Next Monday, we're going to start off with another topic, and we just have a couple more in the class. There's the philosophy of mind. That's the next topic. And then the final topic of the semester is about life and death and what would be the value of a life well lived, what would make a human being's life go well, if anything. So we'll get to those topics, but for now, I just have a few more things to say about that Ted Sider paper that we've been working on. So once again, back to this. Ted Sider, 2005 paper, just called Time. Okay, so I'll quickly just breeze past the first few things in his paper just as a refresher again, and then I'll close the paper by adding the last few notes. So yeah, Ted Sider's overall goal of his paper is just to try and explain to any reader what are the puzzles and philosophical paradoxes and difficulties that have to do with thinking about time in a deep way. He says that the ordinary conception of time that we just have from our everyday life makes sense to us when we're just living and acting, but once we start to interrogate it and really get into the deeper analysis of what time is, it's very hard to articulate, because the problem is that we talk about time as though it moves. A common way of speaking of time, just colloquially, is that time flies, time is passing, it's going so fast, no, it's going slow, but whatever, we talk about it as something that somehow moves. And he says right away this is problematic, because it's defining the concept of motion requires reference to time itself, because if a thing moves in space, that simply means that it is in different places at different times. So, if time is moving, wouldn't that seem to imply that time is in different places at different times? And this is a circular definition. If we try to say time moves because the present moment is moving, he doesn't think that this is a very much better explanation, because if the present moment is moving, then what's it moving with respect to? It would appear as though it's moving by being in different places at different times, and once again, we're faced with the same problem, how to give a non-circular analysis of the movement of time. So he says a better, perhaps, alternative to giving this explanation is to just go with the Einstein theory of space-time. And if we do, then we don't have to give any explanation of how time, quote-unquote, moves, because on the space-time theory, there is no movement to time. There's just a whole set of facts that are contained in space-time, and that includes everything, including past, present, and future, but none of these things kind of passes away or starts to happen. They're just all laid out somehow in the fabric of space-time, and they're all equally real. Now, once we advance this idea of the space-time theory, we still have other problems then that we have to deal with. For example, what is an object then? If the space-time theory is correct and every moment of space-time is existent and equally real, then what are we thinking about when we talk about an object, or even just ourselves? So that's when we got to the point of discussing these space-time diagrams. And these space-time diagrams basically show 3 spatial dimensions and 1 temporal dimension. The temporal dimension, we can call it the t-axis of the graph. On such a graph, we can showcase or visualize the existence of an object as it spans throughout space and time. So it would extend along that temporal dimension of the t-axis. Given how long it exists, there would be more or less extension along that axis. And if we wanted to think about the composition of objects according to this model, well, for each moment that the object exists, there's what we call a temporal part. So the spatial parts are the physical parts that extend through space, but the temporal parts are the whole object at a single moment of time. And these temporal parts are claimed to be real, just as real as the physical spatial parts are. So an object has got both spatial and temporal parts. So there's bits of you that are like future parts and past parts, and they're all collected as one big aggregate on the spatiotemporal graph that would depict your life. Okay, so there are as many temporal parts of an object as there are moments that it exists, which of course could be a huge number given the infinitesimally small duration of a single moment. Okay, so then after that, the last piece that we covered in the previous meeting was if we're going to accept, or at least think about accepting, the space-time paradigm of Einstein, then, well, what does that make us think about the similarities between time and space? Okay, so Ted Sider said that for a full mastery or comprehension of this claim that space-time is the correct theory, you have to start understanding how space and time are more similar than we usually think they are. And he mentions 3 similarities between space and time. Let me see here in this chat really fast, just check in with you. Can you tell me, anybody, just what at least one of those so-called similarities was between space and time that we were going over towards the tail end of the last meeting? There were 3 of them. And I mean, no big deal, but just if you could tell me one of them, and then I could kind of elaborate on it. These 3 similarities between space and time, you know, he gives these like little quick phrases to state these in terms of blank, in terms of blank. Okay, yeah, so good, Cameron. One is in terms of reality. So what is meant by that statement is that in terms of just being real, it doesn't matter how close to you or how far away from you an object is in space. So like if an object, like my watch, is on my wrist, I know it's real because I'm looking at it and I can feel it. But if I take it off my wrist and I put it over here, it's still real. What about if I take it off of my wrist and I put it far away from me, like a football field away? Well, that didn't change the fact that it's still a real existing object. And as I go farther and farther along the scale of distance, the reality of the watch doesn't cease. You know, so I could shoot this thing on a rocket to the moon or even farther, but it's not as if things only exist when they're physically close to an observer, you know? So like the moon is just as real as the computer that's in front of you, even though one of them is much farther away from you than the other one. Okay, so close or far, things are just as real in space. The point is that in time, the same similarity holds. So not just the objects spatially, but events in time are just as much real, whether they're happening presently or whether they're happening far away from your present moment or at any distance from the present moment. So I think I told you guys last week, the results of the presidential election, whatever it is, according to the space-time theory, it's already a real thing. You know, like it's something that exists in the space-time structure, and I guess our current temporal part has not yet been privy to the facts of whatever those subsequent temporal parts of space-time hold, but they're already there, and factually they are already real. So it's not just the present moment that's real, it's also everything that's stretched out in the future or way back in the past. How far away from the present a moment is does not affect its reality, just like how far away an object is in space doesn't affect its reality in the physical sense. Okay, so that was in terms of reality. Then there's in terms of parts. Good, Megan. That was all about the idea that space, there are spatial parts. And so those are like the parts of an object that give it some volume, some mass, some shape. Like my hands are parts physically of me, so those are some of my spatial parts. But the space-time theory affirms that there's also temporal parts, and they're just as real as the spatial parts are. So just as much as you have a left hand and a right hand, you also have like future temporal parts located out ahead of the results of the temporal parts back there before the current president was elected. So at any rate, yeah, parts is another similarity claimed to be present between the time and space concepts. And then the third one, we did cover that, right? Did we get to the third one? Who can remind me that? So you say in terms of parts, in terms of reality, but there was one more. Does anyone know that? Green tea and lemonade is pretty good. But yeah, good. In terms of here and now, the words here and now, that's right. So the point here was just that these two words, one refers to a location in space, that's here. The other word refers to a location in time, that's now. But the thing is, they're both relative words. They're relative terms. The meaning of the words is not something that's fixed and universal. It's relative to the situation where the speaker is speaking. Okay, so if I say here, here where I am, Trump lost, you know, the state. And if you're standing in whatever, like Alabama, you would say, no, here, Trump won the state. So it looks like two different people are saying different inconsistent things about what happened here. I'm saying here he lost, guy in a red state says here he won. But we're not contradicting each other because the word here doesn't refer to only one place, obviously. It refers to the space surrounding the person who speaks. So I'm speaking in this place, which is California, and that's why when I say here Trump lost, that's true. And the red state speaker is speaking in a different physical location, so their word doesn't refer to my place of speech. So that's a relativistic word. The same is true of now. Okay, so with the word now, it's not that there's only one moment that is now. Now is just whenever a speaker speaks. So like, you know, people voting yesterday who are like, okay, now I'm going to go vote. The word now, when they spoke it, referred to November the 3rd at whatever time and date that they said that. But when I say now we're learning about this lesson in Ted Sider's philosophy, I'm clearly referring to, you know, November the 4th, and it's 9:12 a.m. So the word now is also relative, and that's supposed to push back on the idea that there's only one present and that the present moment is somehow special. But really it's not, because any moment could be, relatively speaking, now. If a temporal part of an observer said the word at that given moment in the space-time system. Okay, so that was some recap. Now let me continue from there by adding a couple of more points that he speaks about at the end. So after he presents all this stuff, you know, there's all these theoretical advantages holding the space-time theory as your go-to way of looking at reality, because you're no longer having to give the difficult, perhaps impossible task of explaining how it is that time moves. But there's these weird things about the space-time theory, because obviously it means that all the moments are equally real and there's no such thing as like the open future. Well, he knows that some people are kind of like not so much a fan of the space-time theory. And to be honest with you, I mean, physicists and scientists, they seem to have no problem with it because, you know, they just follow the results of Einstein and others, and it seems like there's great experimental confirmation for that. But I think that sometimes philosophers and just everyday folk look at these results and they just find it so weird that it seems like counterintuitive, and you try to marshal arguments against it, like this can't be true. So he next wants to just consider what a few of those possible objections might be to the whole space-time idea, and that's kind of what I wanted to talk about now. So let me read about that in the book. So I'll find it here. Yeah, so here we go. He says, he kind of gives a quote from like an imagined critic. You know, he says, here's what a critic could possibly say in contrast to this whole picture of space-time. So he says, okay, an opponent of the theory would say this. It's on page 461 on the right column. So past and future objects do not exist. The past is gone, and the future is yet to be. Things do not have temporal parts. At any time, the whole object is present, not just one temporal part of it. There are no future or past parts left out. And now, the word now is not like the word here. The present moment is objectively special, unlike the relative space around you when you say the word here. Okay? And there's also another issue that's sometimes pressed against the space-time theory, which is that according to the theory, nothing really changes. And some people find that so counterintuitive because of the notion that change is so fundamental to what, you know, we believe about reality, that there must be something wrong, something off with the theory. Okay, so let's talk about that. According to the space-time theory, so possible objection. To space-time theory. Okay, so according to this theory, So, okay, so there's just a possible objection that I'm mentioning in this discussion of how people don't all agree with the space-time theory. And one main source of objection or disagreement is on this point. Because if you think about it, right, think of the space-time theory according to what you just know of it for now, having learned a little about it in this class. On this theory, it's like nothing changes at all. And some people say that just is so much a violation of my common sense and my everyday way of thinking about reality that the space-time theory I just must reject. So let's go into that for a minute. How is it that according to the space-time theory, nothing really changes? Can you tell me how that explanation would go? And as you're thinking about it, I'll try and support your thoughts with some commentary and some examples. Okay, so like say, for example, a person changes their look, right? Like, I don't know, say this was like a girl wanted to change up her hairstyle. So she had like really long hair, and she was going through the process of thinking, do I want to cut it? Do I want to cut it? Do I want bangs? Or do I want to, go with a shorter look? And then she just decides, yeah, I'm going to take the plunge and make a big change to my hairstyle, and it's going to change up the way I look. So she had long hair, goes to the salon. Now there's shoulder length, kind of shorter for a girl. Well, I don't want to stereotype, but like stereotypically, that could be a shorter haircut for some type of girl. At any rate, or a guy, from long hair to short hair. But you get the point. Hair's been cut. So after the hair was cut, you'd like to say this person's changed. They had long hair, now it's short. But tell me then, if you can, right? Think critically. Has anything changed according to the space-time theory? Well, you already sort of know that the answer is no. But tell me why not? Why is it that in this description of facts, we would say that there has been no change, really? Even though, to all outward observation, a person had a different hairstyle and now they have a different one. Okay, Megan, you say, I think because all temporal parts already exist, so nothing is really changing, but to our present temporal part, things feel like they are changing. Very good, okay, so what's the physical description of the so-called changed appearance in the space-time theory? Well, what you would say is that one temporal part of this human being had long hair, right? And then another temporal part in the timeline of the same human being has short hair. And that maybe these two temporal parts are like located almost contiguous in the sequence of temporal parts that forms the whole object. But have the two temporal parts changed at all? No. This one lying on that point in the timeline has always had the long hair. And this other one lying at that point on the timeline has always eternally existed and has always eternally had the short hair. So it's like you have a set of dominoes here, and they all have the features included in each one of the elements of the set, but none of them has actually gone through any type of change. So change in that case would sort of be like an illusion. It would be the illusion, as you say, Megan, produced by one temporal part seeing that it has qualitative features that are different from the other ones. Now, is this a fatal objection to the theory? Does this undermine the whole rationale and logic of the theory? What Sider says, and what those that defend the theory also say, is that no, this is really not the deepest problem for the theory, because all it requires for you to do is just to reconceive of the concept of change. In a way, you don't have to think that change doesn't exist, but you have to reconsider what you think it means. So according to the space-time theory, what we call change, like one thing has changed, is instead re-described as the following. Different temporal parts of the same object exhibit different qualities, right? So like, God forbid, but if I got into like some accident and I lost this pinky finger on my left hand today, I would normally just everyday talk say, oh, well, I've lost a finger, so something's changed about me. But in the space-time theory, like in the bigger holistic picture of the universe, we would say, okay, well, one of the temporal parts located at this moment in space-time had that finger. Subsequent later, a different temporal part of the same object didn't have it. And so we have two temporal parts of Dr. Vulich, and they have got different outward features. But throughout all of that, there's been no change to any single one of the temporal parts. It's just laid out there in the time sequence, okay? So he says to this objection, not so bothered by it, because all we got to do is kind of tweak the way we think about change. To give you a metaphor of this idea of how to reconceive of change, a metaphor of driving along a highway is offered to you. Okay, so I'm going to try and draw this little diagram and help you through this thought experiment. Okay, so say that there's a road, like a freeway or highway, whatever. There it is. Okay, and there's this car that's driving along on that road. Now suppose that as it starts its journey on this roadway, it's very smooth. Like it's smooth pavement, it's a nice, well-paved, fresh road. But then as you go a little bit further along, you encounter a part of it that's got a lot of, potholes and cracks, and there's just bumps and stuff in the road as you go over here. But, so the driver who drives through this path, they might say something just like an everyday statement, like, wow, the road has really changed up. This road has changed a lot. It was smooth, now it's bumpy, okay? But in a way, has anything actually changed in a sense on this road? No, I mean, all we really are saying is that the driver is experiencing different parts of it, but the parts themselves have always been that way. Like this part has always been patchy and full of potholes. This part has always been smooth and smooth driving. So what he's calling the change is just the observer observing different points of the road, but the road isn't like changing underneath his feet as he's going. So now, by metaphor, by analogy, in the space-time theory, a person like me or you is sort of like comparable, metaphorically, to the road itself. Like you're the road, because there are different temporal parts along your timeline. They may exhibit different qualities, but they're all laid out there. So like you, as like an older person or having kids or getting married, it's along that timeline in your sequence of events in your life. And you might say when you get married, if you do, wow, something's changed about my life because I was single or I was unmarried, now I am married. But it's like, well, there was this one temporal part along that journey of your stages that didn't have marriage as its feature, and a later one that did, but the whole road itself is like fully laid out and it fully does exist. Okay, so that's his way of trying to re-characterize or frame the idea of change within the context of the space-time theory. Okay, so I'm giving you this heady, hopefully helpful explanation of what the concept is and how it applies to that. And the last thing he says here, and I'm just going to end the Ted Sider article with this, and then we're moving to the next author, which is David Lewis. The last thing he says is a final kind of criticism, pushback from some common sense place about to the space-time theory. Could be this idea. Well, if the space-time theory is really true, and if, like Sider says, space and time are much more similar according to this theory than we sometimes typically think, if there's a true analogy or close similarity between space and time, then you'd expect this similarity to exist also. In space, an object can move like any direction. Okay, so I mean, this marker that's in my hand, I can move it forward towards the camera. I also move it backwards away from the camera. And so it seems like spatial-wise, like in space, an object can move forward, backward, diagonally, whatever direction. But you could argue that that is not the same with time, because in the case of time, things only move in one direction, from the past towards the future, and it can't go any other way. So you might say, here's where the analogy between space and time breaks down. Time has a direction, but space, things can just go in any different direction, and it doesn't have any barrier to that. Let me see your comment, Eva. So is the space-time theory also implying that everything everywhere already has a timeline they are destined to live up to, or no? Yes, it does. It does have that implication for sure, Eva. I would like to, and I think I will do this. I've shared some different supplementary videos and like clips with you guys throughout the semester to sort of reinforce the lessons. But I have a few things from like just popular scientific journalists and journals that talk about this stuff. It's quite interesting, and it's really food for thought. But this is the consensus view, and it's kind of where, you know, contemporary physics meets philosophy. So to me, a person who has a lot of interest in physics and science, you know, I just for the sake of discussion, when I was growing up, I grew up in a household of like an aerospace engineer. That's my Uncle Jim, and so, you know, he was working on all these defense systems, missile defense systems for the U.S. government. And I therefore was instilled at a very young age with like a very healthy dose of respect for physics and science. You know, the theories of Einstein, for example, and the theory of relativity is needed to support the technologies that help power these satellites and things. So, so to me, you know, something that integrates philosophy and science is of great interest. But anyway, that's just me. Anyway, yeah, thanks, Eva, for your question. And I was just mentioning that I'll try to share some literature on the topic too. If you have time, then you can check it out, and that'll even add further context. Okay, yeah, so, but let me see if there's anything I could add to my comment just based on your question. Has a timeline they're destined to live up to? We could say destiny in a way, but destiny also implies that there's like a journey and you're destined to get to the end. But on this space-time theory, it's almost like the journey's already been completed because there are temporal parts of you at the end of the timeline that are already just sitting there. So it's kind of weird, right? You think of yourself as this individual going through space and time. You don't usually think of yourself as like this like kind of accordion stretched out, a whole bunch of parts throughout space-time. But that's the picture that you're being given. Yes, it's true. Okay. Well, what I was just trying to say prior to that is that if you can recall, in space, an object can move any which direction, forward, backward, diagonal, or anything else. But in time, many would argue that that's not the same, because time has an arrow that just goes straight into the future from the past, and it can't loop back on itself. In other words, there can't be something like causation can only go from past to future. If I stub my toe on this table, then after that, you know, I could get like a bruise on the toe. But nothing that's going to happen in the future can affect me now, you know. So it seems like causation only works from one direction to another. In other words, it seems impossible for there to be something equivalent to like backwards causation, which would require time travel or something to the past. Like something in the future seems incapable of affecting anything in the past. Like you can't change the past, but of course you can change, or I don't know if you can say we change it anymore, but the things that you do have causal consequences for the future, but not for the past. Well, what about that? If time and space are so similar, basically the objection says we should be able to conceptualize of time travel to the past and backwards causation. But seems like that is counterintuitive and bizarre, so maybe the space-time theory is false. Well, what does Sider say to this? This kind of provides us with a segue into the next author, because now we can talk for a little bit about the fun, somewhat science fictional almost, but also theoretical concept of time travel. So what he says is that time travel, as strange as it may sound, it's not theoretically inconceivable. In fact, according to the consensus view of time and space that we have today, it's not inconceivable for there to be backwards causation and time travel to the past. The past moments, according to this theory, do in fact exist in space-time, but probably, you know, due to like technological limitations, we cannot achieve the sort of technologies required to teleport, you know, like a whole human body into the past and make changes to the past. But what he's saying is that it's not inconceivable, just at least on a theoretical level, if the technology was present. And so he defends the consistency of some very carefully stated time travel scenarios that we read in, like, you know, science fiction or in film that we see. Some time travel scenarios are sloppy and inconsistent because in them an event happens and then later on is somehow canceled from happening by the time traveler intervening in the past and changing the results. You know, so like that would be like somebody says, oh, we've got to stop Trump from being elected, you know, just hypothetically. And so they want to build a time machine to go back to 2015 and stop him from being successful, you know, before he gets to 2016 election. Now, you know, you could argue that these sloppy, poorly constructed time travel scenarios allow the time traveler to really make the change. So like, by changing those things, the future has been totally changed and he never got elected. But in a well-constructed, internally consistent time travel scenario, you could have the person go into the past but without actually making any changes. And then you'd see like the idea of causal loops and stuff introduced. So what are some examples of like clever and internally consistent time travel scenarios like that? For example, like the Terminator movie series, author Sider mentions those. For example, in like Terminator 2, if you know about it, there's this industry called Skynet that builds cyborgs, and they basically become intelligent and they want to take over the planet, and they start to like enslave humanity and dominate the Earth. So some of the human resistance figures send I guess John Connor back into the, no, John Connor is going to be the resistance leader, and they send a human back into the past to try and protect his mother from being assassinated, because the machines have also sent a Terminator, who was Arnold Schwarzenegger back then, to kill John Connor, who's going to be the leader of the resistance movement. Okay, so like ultimately the guy who goes back to try and protect John Connor's mother ends up impregnating her, and then inadvertently realizes that he's the father of John Connor all along. But at no point throughout the whole movie does anything happen, and then later on is contradicted by intervening in the past. So although they may be a little bit harder to construct, there are at least feasible or theoretically coherent and consistent time travel scenarios that we can see in film. So I guess Ted Sider's response to the final objection there, that objects can move in space any direction, but in time not so much, is that that just sounds like it's impossible, but at least within theoretical discussion, it's not actually impossible. It's just weird. Okay, and so then now that brings us into the next author on this. And we're going to just take our time to cover this final author on the subject of time, and this is David Lewis. Okay, so David Lewis, I know he died in 2001, but let me get his precise dates. Okay, so he lived from 1941 until 2001. So he's one of the great philosophers, really, of the 20th century. A great American philosopher who taught at UCLA. He also, let's see, taught at Princeton for many years, and he worked in Australia for some time. I heard that he was a big fan of Australian culture and the academic culture there too. So in 1971, he first gave this paper as a lecture, and he was pretty young, obviously, still just 30 years old. 5 years after that, it was published in a journal. So what date do we refer to, the original lecture or the published version? It could be either, but we'll go with the earlier one, I guess, is the first. So in 1971, this paper, The Paradoxes of Time Travel. Okay. Yeah, David Lewis, he's very comprehensive, and he wrote, a lot of stuff on all kinds of topics in philosophy: metaphysics, ethics, logic, modal logic, set theory, and he's known for staking out, I guess you could argue, unconventional positions in philosophy. Like, some people think that he holds views that are outside of some people's mainstream idea of, philosophical claims, but he always defends them very, very well with very detailed and comprehensive arguments. He's always been one of my kind of top 5 or so in the field, at least certainly within the modern era. So yeah, he's a great philosopher. He died in 2001, kind of, I guess, a little too soon because he was only 60, but he left behind a lot of great work. There's a classic book of his that had an impact on me, I guess, when I was studying philosophy at UCLA, called On the Plurality of Worlds. And anyway, he's just got a lot of fun stuff. But here we're looking at his writing about the paradoxes of time travel. Okay, so basically, let me just kind of give you the general picture, and then we'll zoom in on the details. But the main thesis of this article is actually quite simple. All he's trying to argue is that time travel is possible, that it's not impossible, that whether or not anybody ever actually succeeds in being able to do it, which is a whole separate proposition, it's something that remains theoretically conceivable. So he's trying to defend that thesis, and he's trying to defend it against the objection that, no, it's too much a paradox. There's something about it that is logically contradictory or impossible. So he's trying to make the case that it is possible. And the weird things about the idea of time travel that sometimes make people think, no way, that's not possible. He's going to claim that those are just weird, but they don't represent things that are inconceivable. Just strange, maybe a little bizarre, fair enough, but not literally impossible. Okay, so time travel is not impossible, but this requires him to go ahead and discuss the so-called paradoxes involved in thinking about time travel. And he believes that if he can show the reader that these paradoxes don't really make it impossible, then he will have won the argument. Okay, so what are the so-called apparent paradoxes of time travel? We're going to walk through them as he discusses them. So, first possible paradox. Well, let me, before I write that out, just give you a little definition. Here's what he says. First, we got to define time travel. And the way he defines it is as a difference between two different frames of time. Okay, so time travel. It is a discrepancy between two different measurements of time. Okay, so let me explain why he offers us this definition of the concept of time travel. It is, again, it's a discrepancy, in other words, a difference between two different measurements of time. So consider this. Suppose we have this guy, and this person walks into this, cylinder type vessel. Okay, now they're inside there, and let's say they're wearing a wristwatch on their arm. So when they go inside there, well, when they first got in on their watch, it said 1 p.m. Okay, they get into the cylinder thing, and they spend inside the cylinder what is on their watch 1 hour. 1 hour of time. Then they exit the machine. Now they're outside. Okay, question for you. If this is a time travel machine, and let's suppose that this person has traveled to the future, then I want you to tell me what should their watch not say, for example, when they get out of the cylinder? If they've gone into the future, then, they walked in at 1 p.m. according to their watch. They spend an hour inside according to their watch. Now they emerge from this thing. If this is a future time traveler, well, Anthony, not so fast, right? Because think about what you're saying. If it says 2 p.m. when they get out, then, okay, good, it should not say 2 p.m., exactly. Because if it said 2 p.m., did they travel through time? No. In that case, is this a time machine? Well, no, if they walk in at 1, they spend an hour inside, and they get out, and their watch and all the other watches everywhere say 2 p.m., then they didn't go into a time machine. They just spent an hour in like a shipping container, and then they got out after 1 hour. Is that time travel? Not really. Or if it is, I mean, you could call it time travel of a kind, but in that case, it's the very boring sort of time travel that I guess we're all experiencing. That's like time travel from the past to the future at a solid rate of 1 hour per hour. And in that sense, all of us are traveling through time, guys. We just traveled through 40 minutes of time when we started this lecture till now. But that's not the type of time travel that people are interested in discussions of the concept. They mean like skipping ahead. And so if he's gone to the future, let's say that he's traveled through time and it's 5 hours into the future, right? So if he skipped ahead 5 hours by being in this machine, then what should it say when he emerges? Right? Because, 1 hour would have just been 2, from 1 to 2, because relative to himself, he's in there for an hour. But if he's going to use it as a time travel, if it is a time travel mechanism, and there's, let's say, a 5 hour, traveling to the future, then the clocks, not his clock, but all external clocks, like on all the other walls and on everyone else's wrist and, on their phones, they should all say what if he took a 5-hour travel into the future? Just making sure you can follow that little part of the explanation. You'd say 6, fair enough. I know this is like it's a 1-hour thing. Do we count the hour in or not? I was going to say 7 because I figured, there's the 1 hour he spent plus 5 that he traveled, giving him 7 p.m. But either way, I think you understand clearly enough that his watch should not show the same time on all the external clocks. His watch should show 2 because it's traveling with him and his watch is a time traveler with him. So he spent an hour of time relative to himself, but he gets out of there and it says it's like 6 or 7 p.m. on that same day. So what was an hour for him was like more than that for the whole rest of the external world and all the other observers. Or if he's going further into the future, right? Suppose that he spends an hour in the machine and he comes out and it's like 2 years later for everybody else. Then he took a much longer journey into the future. Okay, now if this is a past time traveler, right? This is some guy who's going backwards in time. Then when he gets out, after spending a personal hour inside, what should the external clocks say? They should say something before when. If this guy's going not to the future, but the past, then although he seems to spend an hour just to himself in the machine, when he emerges, his watch will say 2, but what should the others say? Something that's like what? Talking about the case of backwards travel to the past. Gets in the cylinder. It looked like when he entered it was 1. It looked like on his watch he spent 60 minutes inside. When he gets out, if he's gone to the past, well, we know one thing. It shouldn't say 2 o'clock, right? It should not say 2 p.m. because that means that there was no time travel to the past at all. And he just continued into the future for an hour. And this was just this empty shipping container with no technology. But if it's backwards time travel, I just want you to tell me that. It should say something that's prior to when. It, meaning all the external clocks on everyone else's arm or on all the walls or in everyone's cell phone. Everyone else's clocks, if he's gone to the past, will not say, tell me, just give me an idea here. Or how about this? I'll give you a specific number. Suppose that he's gone 3 hours into the past. What should all the other clocks say? Now, yeah, it should be before 1. It should be before he left. Or I guess, I maybe gave you a little tricky example because it could be that he goes just 30 minutes into the past, but since he spent an hour relative to himself inside, that's still a marginal amount of backwards travel. But yeah, Drew, if he goes 3 hours backwards, then his clock is going forwards an hour, but he emerges into a world that's 3 hours behind him, and so it's now 11 a.m., 2 hours before when he was supposed to have left. Okay, so this looks to be to some people a paradox right off the bat, because think about what has now been said. If this time travel idea is the right explanation, then there's a discrepancy between 2 different measurements of time. So now here's a question. Say that when he gets out, all the other clocks out there say 6 p.m., but his watch says 2 p.m. Okay? Now, I have a question. How much time did he spend in the machine, or how much time is in between departure and arrival? So it looks like we get 2 answers. It looks like 2 different answers are given to us or suggested to us. One answer on this example is that the time between him getting in and getting out of the machine could be described in what way? As having how much space in time? Sorry, what is your 4 hours and 5 hours? No. Not so much 4. I don't know how we're getting 4, but one possibility is 1 hour, right, Megan? Because you could say that on his watch, he gets in, he spends an hour in, and he gets out an hour later. So that's an hour. But another possible answer is that, like, to everyone else looking at the machine, it would look like he got in there at 1, and then he gets out when? Well, at 6, yes. So 2 answers now. Is it 1 hour in the machine? Is it 1 hour, I should say, in between when he gets in and when he gets out? Or is it 5 hours? Both answers seem right there, and that could be a paradox. How could the same event be separated by 2 unequal amounts of time? Right? Like, say you were going to take a flight from California to New York, and someone asked you, how long is the flight? Or no, you've already finished the flight, and they asked you, how long was your flight? And you told them this. How long was my flight? two answers. It was 3 hours and it was 7 hours. It makes no sense, right? That would sound like to the person to be a straight up contradiction, and you're just talking gibberish. So maybe time travel is gibberish because it involves, at a minimum, a discrepancy between the amount of time the traveler is experiencing and the amount of time everyone else is. So how does that work? Well, here's David Lewis to explain away how that makes sense according to the space-time theory. So, but I'll write the question up here that he's trying to explore this paradox. How can the same two events be separated by two unequal amounts of time? That's the first paradox that he's trying to grapple with. It seems like that might be impossible. How can getting in this cylinder, getting out, be on one level of description an hour, and on another possible description a 5 hour? How is that at all possible? Well, here's what he does say. According to the space-time theory of Einstein, we have been told that there's actually a personal time frame for each individual, depending on their state of motion relative to others. Okay, that's why in the light clock example, one person who's moving fast and one person who's at rest are experiencing different amount of time passage. The rule is that as you move through space faster than a stationary observer, time is passing by slower for you relative to the stationary observer. So fast motion through space equals slower motion through time relative to other observers. So already built into, hardwired and built right into the space-time theory is this idea of variability in the amount of time that we experience if we were able to expose ourselves to forces that could create this variable speed or state of motion. So that allows us to actually refer to two different types of time. And that's how Lewis gets us out of this little difficult paradox. So he says the way to explain this then is by referring to two different types of time, and that is, so two types of time, personal time and external time. Personal versus external time. So personal time is like the time that you experience personally, and it would be equivalent to the amount of time measured on your personal wristwatch if you keep it on your wrist, so it's like attached physically to your body and it has your own state of motion. So personal time, the time experienced by the, let me erase this to give myself a little more room. Sorry for that, but I just need a little room. Personal time, the time experienced by the traveler, the individual traveler, as shown on their personal wristwatch. As shown as measured on their personal wristwatch. Now, external time would just be time as measured by all external observers and clocks. So personal versus external time. I know we're running low on time for the moment, but we will just pick right up with this on Friday. Overall, this is the explanation that reduces this paradox to something manageable, because basically the guy spends 1 hour of personal time and 5 hours of external time. And according to the space-time theory of Einstein, there's no contradiction between saying those two things, because in fact, on this theory, objects that have different state of motion through space-time actually do move at different rates through time. So in the case where one person had the access to a time travel device, their personal time would diverge greatly from the external time enjoyed and measured by all the others. So that shows us that this apparent paradox is not really so paradoxical. once we understand that in the space-time theory, time actually does flow at different rates for different people, depending on how fast or slow they are moving in space. Okay, guys, so just a quick little starting look at the David Lewis article. We'll finish this on Friday, and then next week we'll get started on another topic. But for the time being anyway, thanks. Have a great day, and I guess I'll check back in on you guys on Friday. Okay, thank you. Bye-bye.